Okay, so today let's investigate the area of parallelograms some more. And let's establish the area formula for a parallelogram. This is also the makeup module for any incomplete grades. So pay attention. So on this slide, it says the dashed line is the height in each figure. What do you notice about all these shapes? What do they have in common? All shapes have four sides. We call four-sided shapes quadrilaterals. Laterals. Okay. Another thing I noticed is that all the shapes are parallelograms. If you notice, the parallelograms are, well, what we should remember about parallelograms is that it has two sets of parallel lines. So two sets means here's a parallel line and here's a parallel line. These two lines are parallel to each other. That is one pair or one set in the shape, in this whole shape. If we look to the side or the left of the shape, this slanted line and this slanted line are also parallel to each other. They will never touch. So this shape has one, two, okay, one pair, and then two pairs of parallel lines. I also noticed that all shapes have a height and a base. Okay. So to the next slide, number 2. In the images, the dashed lines are supposed to represent the height of the parallelogram. So dashed line are these dashed lines. They are not filled in, but they are dotted. And it's supposed to represent the height of the parallelogram. Select 3 statements that are true about bases and heights in a parallelogram. Okay, so these are our non-examples, and these are our examples. So we're going to use these to pick the correct statements. Statement A, only a horizontal side of a parallelogram can be a base. Horizontal is this long line right here. So that's a base. The base over here is not horizontal. It's kind of going a little bit vertical or slanty. And then over here, they're saying that the height, the base, sorry, this base is actually going vertical and that this base is going slanty. So we have bases going all over the place. So I don't think A can work because it says only a horizontal side of a parallelogram can be a base. And that is horizontal, but the base is located in different spots in the different examples. So A is out. Any side of a parallelogram can be a base. Well, we just talked about that. The base does not have to be horizontal. It could be on the side. It could be on the longer side. It could be on the shorter side. So any side of a parallelogram can be a base. A height can be drawn at any angle to the side chosen as the base. A height can be drawn at any angle to the side chosen as the base. Okay, so they're saying the dashed line is the height at any angle. So right here it goes up. From here, well, what I notice is every dashed line comes right off of the base and it forms a 90-degree angle. So we have our base and we have our height. Let's see if that is the same and true for the other ones. Here's our base, and immediately perpendicular to it is the height. If this is our base, our height crosses straight through it and they create a 90-degree angle. And the same thing for here. Even though the height is not inside of the shape, we look at the base and we draw it out, and then we go from the bottom or the base to the top of the shape. Okay, So C is out. It's not any side. It's the side that is perpendicular to the base. A base and its corresponding height must be perpendicular to each other. Oh, I just said that. So that is true. The base and the height must be perpendicular. Perpendicular is a word, again, that just means that it's going to form basically a cross. Let me show you. So what they mean is perpendicular, if that's a straight line, and that's a straight line, they basically make a T or a cross, and there's a 90-degree angle inside of there. So here's my base, and there's my height. It also makes a 90-degree angle. Here's my, oh, that's not straight at all. Here's my base, that's not straight at all. Base, height, 90-degree angle, base, and height, 90-degree angle. That's what perpendicular means. So D works. Letter E, a height can only be drawn inside of a parallelogram. Well, if we look at our examples, I notice that this dashed line for the height is outside, and they say these are examples, so I'm going to say E is not true. I think I know you can draw the height outside of the shape as well. Letter F, a height can be drawn outside of the parallelogram as long as it's drawn at a 90-degree angle to the base. So here's my base, and there's my 90-degree angle. So that is true. And for this one, if you notice, these angles, when they cross the base, are not creating 90-degree angles. What does B stand for in this figure? B stands for base, not button. What does the dashed line labeled H stand for in this figure? And if you forget how to spell, you can always come back, check out how to spell it. H stands for height, not Heidi. Okay, next up, a card sort. Sort the cards into 2 groups. Start with the green and red cards first. Use them as the tiles for your groups. Proceed to the next slide to get the cards. All right, so I'm going to put this over here and green over here, and I'm going to start moving some of these around. So the goal is I want to find all the shapes that make perpendicular lines, and they create a 90-degree angle. I do not see a 90-degree angle. This shape or this line is not perpendicular to the base. It actually creates an acute angle if you look at it that way, or an obtuse angle if you look at it that way. So that is a not correct example. For this one, base goes here. Height is going at an angle that is not perpendicular. I don't see a 90-degree angle, so I'm going to put it over here. Let's do the most obvious ones. Okay, so they're saying the base is here, and the height is kind of going at an angle that is not 90-degree angles. So let's put that in the non-examples. All right, looks like everything else has a 90-degree angle. Let's see. Okay, we have our base over here, and we said the height can come on the outside. They do form a 90-degree angle. That's very nice. I will put that as a correct example. Here's my base, and coming straight out of it at a 90-degree angle is the height. So that is an example. Gotta put that right on top. And then for this one, they're saying if that's my height, shouldn't height be the dashed line? But they're putting the base at the bottom. And I would think if I was going to do the height, it would have gone straight up and down, literally like straight up off of the B. So that's not an example. So I'm going to put that in the not correct example. Over here, they put the base up top, but they immediately drew the height straight down, and it creates a 90-degree angle. That is an example. Okay, over here, here's my base, and coming straight off of it, making a 90-degree angle is my height. That is an example. over here, base, straight up, height, and they create a 90-degree angle. Excellent. Let's go on to the next one. All right, all of these figures are correct. Look at the B and the H, the base and the height for each card. What do they have in common? I noticed that they create perpendicular lines that form a 90-degree angle when the base and the height meet or cross. I also noticed that height was represented with a dashed line. What's incorrect? This figure is labeled incorrect. Explain what's wrong with it. Okay, so, we talked about this. So I thought the base should be there, not here. And the height should be on this dashed line. I see that the base, well, let's start with the height. I see that the height is not perpendicular to the base. The height line should have been placed over the dashed line, and the baseline should be moved to where the height is. I'm going to show you. So basically what I'm saying is that this B, the base, should be there. That height we got to get rid of. So I'm going to say B should go there, and then the height should go there. That's basically what we're saying. And don't forget, they form a 90-degree angle. If that's my base, we could literally even move the computer so that the baseline is horizontal, but we'll always see and notice that the height line will go straight through it and create a 90-degree angle. Okay? Okay, copy this table into your composition notebook or a piece of paper. Let's go to the next one. All right. It says complete the table for these figures on a piece of paper. You don't have to do it on a notebook. Record the base, height, and area of parallelograms A and B. Okay, so I noticed that the formula for area is base times height equals A, right? So my base, if that's my base here, my base is going to be 1, 2, 3, 4. And my height is going to be 1, 2, 3, 4, 5, 6. Okay, so the base was 4. The height was 6. Remember, we're multiplying. And the area is 24 square units. Okay, for my parallelogram, my base, I'm going to put at the bottom, and I'm going to say from corner to corner or vertex to vertex, 1, 2, 3, 4, 5. My base is 5, and my height, I'm going to go straight up like that. And I guess I could make a dash line. Okay, there's my dash line. So my height is 1, 2, 3. Okay, so my height was 3 and my base was 5. We're going to do 5 times 3, and that's going to give us 15 square units. Don't forget your 2. Have extra time. What is the sum? And when you hear the word sum, what does that make you think of? Sum reminds me of adding, and that's the word we use when we are finding the answer to an addition problem. So they say, what is the sum of the areas of these two figures? So it looks like we are going to add the two areas. 24 plus 15. 9 is too low, 18 is too low, 24 is too low, and 15 is too low. Wow, I didn't even have to solve it. But if I was, 4 plus 5 is 9, and 2 plus 1 is 3. On the base and the height of each figure, then multiply them. Multiply the base and height. To find the answer to part 2, they just wanted me to add the answers up. The answers I found to the areas, which was 24 plus 15 equals 39. Oh, look, the answers are there for us. Complete the table for figures C and D. Record the base, height, and area of the parallelograms C and D. Have extra time. What is the sum? Remember, sum means to add of the areas when you find that. So you know what? I'm going to let you answer this one on your own. Let's go to the next one. Oh no, give you the answer. Oh no. Okay, so the lesson summary is the base B of a shape can be any side. The height H of a shape must be perpendicular, 90 degrees to the base. Area formula for a parallelogram is area equals base times height or base times height. When we put letters together, they mean to multiply. When we put a little dot in between either letters or numbers, we're also meaning to multiply. All right, I hope this was helpful. Please finish the rest on your own.